everyone. Okay, so we're going to do a little bit of a different lesson. So we're still working in Module 2. We're on Topic 3. And this is going to be a lesson that is fit in between Lessons 2 and 3. So we're kind of in between Lessons 2 and 3. So this lesson is on graphing ratios from tables. And I'm going to give everybody in class this note sheet. So if you are absent, you can get this when you get back. If you want to screenshot it and use the markup feature, you may. If you have a way to print it out at home, you may do that as well. Okay, so let's get started. Vocabulary. An ordered pair is a pair of coordinates written with parentheses, always in the form of x, comma, y. And we've talked about that already this year. Keywords and phrases to look for in recognizing ratios. Again, this is a review. To, for every, for each, or out of every. A ratio table, equation, or double number line can be used to create ordered pairs. And we've done that as well. These blank can then be graphed on the coordinate plane to represent the ratio relationship. And that's ordered pairs. So the ordered pairs can be graphed. I'll just slide it around here a little bit. Okay, so let's get started with our first example. It says school t-shirts are $10 for one. Use this information to fill in the table below. So if one t-shirt is $10, then two t-shirts are $20. Three t-shirts are $30 because it's times 10 on each of these. Each one is 10. So 4 t-shirts is $40. Okay, so we have the total number of t-shirts times 10. Remember, when a number and variable are right next to each other, it means multiply, equals our total cost. So if we have one t-shirt, 1 times 10 is 10. If we have two t-shirts, 2 times 10 gives us 20. Our cost is 20. 3 t-shirts, 3 times 10 is 30. Our cost is 30. So this column is C and T and C in our equation. This is also the X and the Y in the ordered pair. So in Mathia, they do ask you to write down an equation for scenarios like this. They have you figuring out different patterns that you're doing, and then at the end they have you write the expression, and then they have you doing a variable, and then the an equation like this. Or maybe I guess they do a variable first and then the expression, which would be that. Okay, so but then we can graph those as ordered pairs. So we do 1, 10 and 2, 20, 3, 30, 4, 40. All right, so remember the first number in our ordered pair is plotted along our x-axis. It represents the t-shirts. So, and you can see here we had the t-shirts. So this is our x-axis and this is our y. So to plot the ordered pair, we're going to go on the x-axis over to 1. On the y-axis, we're going to go up to 10, and we're going to put it at. So 2 20s, we're going to go over to 2 and up to 20. We're always starting back here at the origin. Over to 3, up to 30. And over to 4, up to 40. Now, if we didn't sell any t-shirts, if we had 0 t-shirts, it would cost $0. So we know that our the origin is one of the ordered pairs that we could put here. So this actually forms a straight line. And using a straight edge, we could connect that. And it would continue on. Let me slide it over now. And then we could use the graph to answer. So at 8 t-shirts, it would be $80. And you can see it crosses right there. Okay, so let's move on and take a look at the next one. To make cotton candy, you spend Flavored sugar in warm air. You need to use 2 cups of sugar mixture for each cotton candy cone. Complete the table below, then use the graph to represent the relationship. Okay, so every one each cotton candy cone is 1 cotton candy cone. You use 2 cups. So every one is 2 cups. That's going to give us the ordered pair 1, 2. So if we have 2 cups, so all of these are going to have a times 2. So 2 times 2 will give us 4. So we have 2, 4. Three times 2 is 6. So we have 3, 6. 4 times 2 is 8. We have 4, 8. 5 times 2 is 10. And we have 5, 10. So let's plot them then. So our ordered pair 1, 2. So we go over to 1 and up to 2. We go over to 2 and up to 4. We go over to 3 and up to 6. Over to 4 and up to 8. Over to 5 and up to 10. And again, would 0, 0 make sense? If we sold 0 cotton candies, we wouldn't need any sugar. So it does make sense. Okay, and the next one, Sally. Sure, I got all of that one in the kind of a glare. There we go. Hold that there for a second for you to be able to see this. Okay, next one. Sally spends her weekend making cookies to sell. For each dozen, she charges $15. Complete the table below and graph the ratios on the coordinate plane. So for each dozen, so that's per 1 dozen, it's $15. So $15 for 1. So each of these is a times 15. So 15 times however many dozen. So 2 times 15 is 30. So we have 2, 30. 4 times 15 is 60. So we have 4, 60. And then 6 times 15 is 90. So we have 6, 90. Now we need to graph that. Okay, so let's go ahead and graph it. So we have 115 over to 1 and up to 15, 230 over to 2 up to 30, 4, so we skip the 3, 4, 60, and 6, we skip the 5, 90. Okay, so then it says, actually let me try to use a straight edge here. Just gonna get some papers. And we know if we had 0 cookies to sell, we'd get $0. So it's going to go through 0, 0. So I'm going to connect my dots as neatly as I can. And then let's answer the questions. It says, how many dozen cookies will Sally need to sell to bring in $240? And then how much money will Sally bring in if she bakes 9 dozen cookies? I want to do this one first because we can see it on the graph. So if we go over to 9 dozen and we follow it up, it crosses right here, which is at $135. So what about 240? 240, I could still use the graph to do this. I see that $120 crosses the graph exactly at 8 dozen. So if 8 dozen is $120. And then how many dozen would be $240? So that's a times 2. So a times 2. So it should be 16. The other way we can solve this is we can take the $240 and we can plug it in for our cost, our total cost. 15 dozen times some number equals 240. So 15 times what equals 240? Well, if I don't know, I could divide by 15. And then when I do 240 divided by 15, I will get 16. So 16 dozen is our answer. Okay, moving on. Callie charges $6 per hour to babysit. Complete the table, then show the relationship between the hours she works and her total earnings. Then use the graph to represent the relationship. So $6 per hour. Now notice they don't give us 1 hour. So if it's $6 every hour, I kind of wrote this down. $6 times every hour is going to give us the amount she earns. So $6 times 2 will give us 12. So we have the ordered pair 2, 12. So times 6 on each of these. So we have 24, 36. So 6 and 36. And 8 and 48. And then need to plot them. So over to 2 up to 12. 4 and 24, over to 6 up to 36, over to 8 up to 48. And if I connected those, I should go through 1 6. 1 hour should be $6. And we know if she doesn't babysit at all, she gets $0, so it goes through the origin. Now, in order for ratios to be equivalent, the line has to go through the origin. If it doesn't go through the origin, then they are not equivalent ratios. And 1 6 does, in fact, work on there. How many hours must Callie work to buy the new pair of shoes that cost $50? So let's find $50. So 50 is going to be halfway here between this. So how many hours will she need to work? So $50, here's 48 and here's 54. So the $50 falls about right here in the middle. Okay, so she's going to need to work more than 8 hours, but not quite 9. Okay, so she'll have to work at least 9 hours, right? Because 9 times 6 gives us 54. Okay, she must work 9 hours. Must work 9 hours. If we wanted to figure it out exactly, like if she could truly work just down to the exact minute, then we would divide that. We could do 6 times the number of hours equals 50. So we would just divide by 6. So hours equals 50 divided by 6 gives us 8.3 repeating. So not quite 8.5 hours. So assuming that she would have to work in whole hours to babysit, we're going to say 9 hours. Mark takes a walk every day with his dog. The graph shows the relationship between the number of days he walks and the total distance. Use the graph to fill in the table below. Okay, so now we're going to take the points from the graph and we're going to fill them in here. Let me zoom out a little bit. Okay. So 2 days is 10 blocks. So that was the ordered pair 210. 4 days was 20 blocks. So it's 420. 6 goes up to the 30. And 8 goes up to the 40. Okay, then it says, how many blocks does Mark walk per day? Ooh, look at that typo. Underline that 3 times. That should be capitalized. Okay, how many blocks does he walk per day? So all of these, what is the unit rate then? So if it's 10 blocks per 2 days, that would reduce to 5 blocks in 1 day. Does this one do the same thing? 20 blocks in 4 days. Is that equivalent to 5 blocks in 1 day? Divide these both by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. What about 40 blocks in 8 days? Is that equivalent to 5 blocks in 1 day? Yes, it is. Divide by 8. 40 divided by 8 is 5. 8 divided by 8 is 1. So he walks 5 blocks per day. Okay, so that is the unit rate. How long will it take him to walk 100 blocks? Well, let's figure that out. So 100 blocks. We could just use our equivalent ratios. We have 5 blocks in 1 day. So that's blocks per day. So how many days for 100 blocks? So how do we go from 5 to 100? We're doing a times 20. So a times 20. So it should be 20 days. It also asks us to write the equation. So we did, if it's 5 blocks in 1 day, so it's 5 times the number of days equals the total blocks he walks. Oh, I ran out of room. Okay, moving on. Oh, that is it actually. Okay, and we will see you on the next video where we will look at lesson 3.